So welcome to, again, Stormwater Awareness Week 2021. And we're so glad that you could be a part of this. And today's topic, or this workshop's topic, is SWPPPs that work and don't break the bank. But before we jump into that, I wanted to test your knowledge about how much things cost. And so I'm going to throw up a poll onto your Zoom, so you get a chance to vote. So here it goes. And it's, which is the least expensive to install? Fiber roll, compost socks, or silt fence? Fiber rolls, compost socks, or silt fence? Now I'm talking about a correct installation. There's no cheaper BMP than fiber rolls just flung out onto the ground. But that's not what we're talking about. And in this workshop, we're actually going to talk about how to do that.
Well, that makes me want to change my answer to compost.
Oh, don't give it away. Yeah, actually, I'm seeing the majority right now are coming through with fiber roll, and one person has voted silt fence. Now, if you haven't voted yet, or you just joined us, we have a poll question on the screen. We're asking, of these three BMPs, which is the least expensive, fiber roll, compost socks, or silt fence? So go ahead and vote if you're just logged in, and see what you come up with. Just another moment. All right. Quick, if I'm going to end the poll, you haven't voted yet. All right. Well, the majority says fiber roll, and that is actually reflective very much of the majority opinion that fiber rolls are the cheapest BMP. But in reality, they're not. In fact, if you just compare material to material cost, silt fence is actually by far the cheapest. You can go to Home Depot and buy any of those. Not compost socks, but you can buy fiber roll and silt fence. And silt fence runs right around $22 for a 100-foot roll, where fiber rolls are roughly $35 for a 25-foot roll. So right there, just on a linear, per linear foot basis for the purchase of the product, silt fence is much cheaper. Now, the difference between silt fence and fiber rolls when it comes to installation is actually, if they're installed correctly, it's minimal. Now, true, silt fence have bigger stakes, a little more muscle maybe needs to go into it, but they're only pound in every, let's see, I think it's every 8 feet, 6 to 8 feet, where fiber rolls need to be staked every 4 feet. They both need to be keyed in. And so again, there's logistics involved that might make one more or less expensive in a certain scenario. But the correct answer to this poll is actually silt fence or compost socks, depending on where we're installing it and how we're installing it. Fiber roll is actually usually the loser when it comes to cost per linear foot when installed correctly. All right, great. So here's the results from that poll. And let me throw up another question for you. And so here it goes. Let's see. Hold on here. What happened to my poll? Let me close that. Maybe I had to do that. Try the second poll. Well, I might just have to ask you if it doesn't come up here. All right, well, the second question I was going to ask is the price for jute netting on a steep slope. So you've all seen when jute netting has to go on a steep slope. how much does that cost? And I'm going to give you 3 options.
I just put it up
per square foot.
poll.
Oh, did you find it?
It should be up in the poll.
Okay, let me try it again. There it is. Is it on the screen, Rebecca?
Yeah, it's on the screen.
Good. All right, good. People are voting. Thank you, Rebecca. All right, how much does jute netting cost installed on a steep hillside? And look at, we're getting lots of votes in. All right, we have 11 out of 11 have voted. All right, who's the brave soul that voted for 63 cents per square foot? You want to unmute yourself or raise your hand? Who was that? Clarence, I should have known, Clarence. I should have known. You're right. Clarence is right. Jute netting is not that expensive. It's 63 cents per square foot. In fact, I have a quote right here on my desk that I based that off of. And here's the point that I'm trying to drive with these questions, and this will segment into our discussion. How many times have I gone on a job site and the contractor or whoever I'm talking to, project manager or owner representative, whoever I'm talking to, you know, the one who's responsible for the purse strings, how many times have they said, I can't afford that. That's just way out of our budget. We can't afford that. That will break the bank. Well, lots of times, it's helpful to have these numbers in your hip pocket. Based on our first question, I've had lots of times where, for various reasons on a SWPPP, I will spec out silt fence instead of fiber roll. And the contractor will see that and go, oh, why'd you do that? You know, that's ridiculous. You know, that's just too expensive. Yeah, and so usually what I'll do is I'll actually go to Home Depot's website, clip the price of a roll of silt fence, clip the price of fiber rolls, and email or text that to them and go, well, actually, it's not. Silt fence is less expensive when it's properly installed. And so it's helpful lots of times to have those in your hip pocket. All right, well, with that, I'm going to jump into my PowerPoint, and Rebecca, there's a few people still coming in. So, all right, here we go. And let me just grab, so I can see the chat. Just give me a second to get situated here. There we go. All right. Great. So let's talk about this. When it comes to complying with the construction general permit, is it just the person who holds the purse strings that makes the determination? Well, many times, yes. They're the ones that are really the ones who will determine to what extent can you be compliant. But, you know, like I just mentioned, how many times do we hear the phrase, it's too expensive. I can't, you know, we can't afford that. We cannot comply with this construction general permit because of that. And so what we want to talk about today is how to come up with a workable solution, kind of a balance between two different worlds or two different perspectives. And so let's look at the contractor's perspective, and then we'll look at the flip side of the coin, the water board's perspective. And in this talk, hopefully we can get to where we can marry those two perspectives and have a workable compromise that will protect water quality, that will comply with the construction general permit, but that won't break the bank won't cause too much grief to the person who holds the purse string. So first off, what is the contractor's perspective? Well, we're talking about a contractor who actually cares, who knows compliance is important, who's really trying to do a good job on every aspect of the project. And so their perspective is they want something that's realistic. They want something that is workable and that will work for each phase of the project. Now, that's a good expectation. And one of the problems I see with SWPPs, and one of the reasons why SWPPs are not workable many times, is that the SWPP writer doesn't understand the contractor's perspective and doesn't understand basically how projects progress. Unfortunately, many times in our industry, the SWPP writer is someone who's right out of school. They haven't really been on a construction site a whole lot. They went to work for a consulting firm, and basically they were given the job to write SWPPs or write SWPPs under a QSD. And so sometimes what they'll produce is maybe it looks good on paper, but it's just not realistic when it comes to execution in the field. And so what's really important for a SWPP writer is to understand how each project progresses from one phase to another, from maybe the demolition phase to the grading phase to the streets and utilities phase. How long will those take? What will the site look like at that? And then finally, when they get into vertical, how that progresses. But what does the site look like around that when vertical construction is happening, and then ultimately into stabilization, landscaping phases? The contractor's perspective too is not only do they want a SWPP that's realistic for each phase of the project or throughout the project, they need something that is doable. Now, that falls into different camps. You have fiscally doable, and we kind of address that. And sometimes you have contractors that are just whining about the cost no matter what the costs are, but other times the costs are very much substantial and are a very much an issue. But you also have a more pragmatic aspect to doable is let's take track out control, TC1 that's going to be installed. And when do you actually put that in? Now, of course, if you went to a QSD class, QSP class, or heard any workshop, they're going to say, well, right at the beginning is when it needs to go in, right at the beginning. Well, that's true to a certain extent, but at what beginning? I mean, many times what you're doing, very first thing is grading the whole site, and that track out control is actually in the way. And the site is not ready to receive that at that moment. So we need to time our BMPs so that it is doable for the contractor and it's not getting in their way. Cost effective, we've already talked about that. And that's kind of the whole point of what we're going to be talking about in this workshop is how to make them cost effective. Not overkill. I have seen different examples over the years that are even rather laughable when it comes to BMPs. One of the ones I've seen many times over the years is doubling up on BMPs. And so you'll have a SWPP writer who's really maybe nervous about sending poor quality water off site. And so they'll surround the site with not only silt fence, but just for good measure, they'll line it with fiber roll too. If they had their way, they'd put compost socks there as well. Is that necessary? Is and it's not. It's not. Usually what that is a result of is a SWPP writer who doesn't understand how the BMPs work. And that when we put up a sediment barrier like that, all we're doing is slowing the flow down. And we're getting sediment to drop out. We don't need double or triple layers. We're not filtering water, we're just slowing the flow down. And so there's so many places where you can go into, it can get overkill quickly, and it's a good SWPP writer who will look at the situation, look at what they're at the phasing of the project, and come up with something that's going to work, but not cause problems. Rebecca, it looks like there's some people trying to get in. Another aspect from the contractor's perspective is that they want to be kept out of trouble. So lots of times too, you know, at QSP, it sounds kind of strange. I don't want to spend any money, but I want to be in compliance, and I don't want to get in trouble either. And so that's the contractor's perspective. Now let's flip the coin over and look at the other side of the coin, and that's the water board's perspective. And theirs is, okay, we have this permit, this NPDES permit, the construction general permit. We need compliance. The BMPs, the mandatory BMPs in there that are mentioned in there, they need to be done. They need to be implemented. The water board's perspective is to protect water quality. And how we do that is minimize erosion happening on the site, either by water or wind, or even big heavy equipment. We want to minimize particles from becoming detached. And then we want to, and the water board also wants to eliminate off-site sediment deposition. And as you're going to see, the goal is actually to get sediment to deposit, but on-site, not off-site. And then the water board's perspective is, we want the site buttoned up at the end. We want a fully stabilized site when the project's all over, not bare soil that can continue as a continuing erosion source, but we want to see stabilization through either the development or landscaping, grass, but basically where soil is not going to erode any further. And ultimately, their goal is to have water quality protected. So we have these seemingly opposing perspectives at times, but what we're going to try to do is bring these perspectives together to work towards a common goal. And so let me click here. All right, so there's one more though that we need to understand, is to understand your BMPs. And so we're going to be talking about that, scheduling when it comes to BMPs, perimeter sediment controls, effective soil cover, track out control, and final stabilization. Oh, did I lose my audio? Let me check here.
I can still hear you.
Okay, yes, Cindy, maybe you can text Cindy, Rebecca.
I can hear you, John.
All right. I was going to ask the lame question. Anybody not hear me? Okay. All right. So let's we're going to go over the BMPs, and so let's talk about scheduling. Okay. And when do all good projects start? October 1st, right? This week it comes October 1st. That's why we do Stormwater Awareness Week. For whatever reason, it seems like the majority of projects start this time of year. That's kind of unfortunate, because one of the best BMPs that you can take advantage of is scheduling. And if you want to get the biggest bang for your buck when it comes to the cost of having best management practices, the best thing you can do is schedule the project so that it coincides with the dry season, or at least portions of the project to correspond with the dry season, such as the grading phase. If I can get the grading phase and the utility and street phase done before the rains start and get surfaces paved, then that is a really good BMP, because as you're going to see, I'm going to show you some photos here soon, that it will save you huge dollars when it comes to controlling mud, controlling track out, and keeping your site clean and water quality good. So as much as you can, try to get that schedule to work for you. Now, I understand that's not always an option, unfortunately. Lots of times you need to, the project needs to move on. In fact, maybe you had every intention, or the LRP had every intention to start the project early. But you know how permitting goes with municipalities, and things get delayed, and we still want to get this project going this year. And now here we are, October 1st. So there may still be some things that we can do about that. So, but talk to the contractor about the project phases, see what could be done early, and be asking yourself the question, whether you're writing a SWP or whether you're implementing a SWP, what can I do today to help my situation later? So we know the rainy season is going to come, okay? So it's last week of September right now. We know it's coming, but we just don't know when exactly. This year, fortunately, it seems like we're getting more storm activity. I don't know, we'll see what happens, but hopefully those rains come in early. But how can I get this site ready, not only by installing BMPs, but maybe pushing certain phases forward quicker, like getting the asphalt installed. When maybe I can get a first lift of asphalt down early on during the project and move things along. So here's an example of bad scheduling. Two projects. In fact, I think one of those is from Patterson. I won't say which, but my friend from Patterson might actually recognize it. It's actually several years ago. So, but in both these cases, they did not need to wait so long to put in the roadways. The one on the left is actually an industrial facility that they were building, and they had started this project early on in the summer. But for whatever reasons, and they probably have their reasons, they waited to put the roadways in. And this happened a few years ago. It wasn't last year because it was relative drought year, so they might have not had these problems. But it happened during a very wet season. And you can see in that left-hand picture that roadway's been cut down. In fact, it was cut. What would happen was they'd get a rain event. This would turn into basically chocolate pudding. And because they're still trying to get construction to happen, where they're building the industrial plant, they had to get equipment in and out, and it kept sinking in the mud. So they had to keep over excavating and over excavating. And do you think that costs a lot of money? You bet. A lot of money, lost time, lost effort, putting labor on that you could have been putting elsewhere. And all of that could have been prevented by putting in that roadway earlier in the project and giving a stabilized access to the work site. But it would have also hugely helped with the erosion and sediment control. They were fighting water quality issues at just as much as they were fighting getting equipment in there. As muddy as it was getting in, that's how muddy the water was flowing off site. And all of that could have been prevented quite easily by scheduling. The next picture is a fast food restaurant that was going up, and same issue. This project started early in the summer, if not even late spring. They had the whole dry season basically to work on this, and they had every opportunity in the world to have put in the paved parking area. Now, why do people wait on that? Well, the traditional thinking is that you don't want to put your pavement in until the very end, because you know why? It gets scuffed up, it gets marked up. Somebody moving a piece of equipment across, or it's just not going to meet the owner's expectations if you pave it early, and then when you turn over the project at the end, the pavement's going to look awful. The way around that is to do a 2-lift process. So you put in your first lift first, and you work off of that. And then towards the end of the project, you then put in your second lift, and then you do all your painting and all that as well. Now, does that cost more money? You bet. It costs a little bit more money to do a 2-lift process. But we're talking about writing smart SWPs, and we're talking about saving money on the long run. And they had this very same issue that the industrial site had. They had equipment sinking in the mud. They had access issues. They had water quality issues. The city was on them about the water quality leaving the site. So they had to put in additional BMPs. They had to do additional sweeping. You know, I'm willing to bet that both those projects spent way more than the difference of a two-lift asphalt process in the BMPs that they applied, and all the extra labor that they applied to dealing with the mud. So there's lots of reasons why to do that. Yes, there's a great comment. Another option is to pave and then seal coat after construction's done. Yes, right. I absolutely agree. You want to talk that through with the owner, make sure the owner specs, the owner's going to be happy with that and will accept that. But I agree, there are options. Now let's talk about perimeter controls. I threw out that as our survey question. And when it comes to perimeter controls, perimeter doesn't always mean perimeter. I hate you. You know, you say you want perimeter controls, and so what do people do? They surround the site with silt fence. They surround the site with fiber rolls or compost socks or something. And I have seen so many job sites waste money on perimeter controls that were absolutely unnecessary. For years, we've laughed about a job site here close to our office here that they put fiber roll right up next to a concrete retaining wall. You know, what did that do for them? Nothing. Why was that done? Was it just, you know, was it because they were just not smart about it? No, you know why it's done. In fact, I've asked many contractors about it, and usually it's laborers who are putting it in. They're like, hey, I understand, you know, even when I've asked them, they go, I understand, yeah, this is a stupid place to put fiber roll. But the boss told me to put the fiber roll in just as the SWPP called it out on the SWPP map. And so that's the way I'm doing it. And I can understand that logic. So it's the SWPP writer, you know, we're talking about writing SWPPs that are doable, writing SWPPs that are cost effective. It's the SWPP writer who's got to be calling out the appropriate perimeter controls for the appropriate locations. Now, what happens if you got one of those SWPP maps calling out for perimeter controls in a ridiculous spot? What do? By the way, I don't have to monologue this whole time. So if you guys want to interact through chat or unmuting yourself, feel free to do that. Well, if that was you that got a SWPP map with some ridiculous call outs for fiber roll locations, then what you want to do is get a hold of your QSD and say, look, did you know there's a retaining wall here? Or did you know this is at the top of the hill? You know, why are we protecting it here? And so sometimes there could be a good legitimate reason for putting something in a place someone in the field thinks is ridiculous. But many times, you know, I've made mistakes. I've missed things on the drawings. And many times, you know, the QSD is at fault. So whether you're writing a SWPP or whether you're the recipient of a SWPP map that's calling out for perimeter controls, do some common sense with that. and do some fact checking and see if this is really the best idea. And also, bad installation or the wrong control measure will cost you money. Now, we talked about fiber rolls being flung out onto the ground. In fact, this week, in fact, even right after this meeting, I got to go out to a job site where they did just that. And then they thought, well, okay, we understand what's going on. We'll weigh them down with some gravel bags, some sandbags we'll put on top of the fiber roll. Not a good idea. And here's why, especially if it's on the perimeter where we might be sampling. And in fact, well, I'm going to show you a graphic here soon, so maybe I'll back off on that. But it's a bad idea because there's some unattended results. Those fiber rolls act like basically little mini dams, and they stop water. Water builds up, and as it builds up, it gets head pressure. And then if that fiber roll is not secured properly, meaning keyed in, staked in every 4 feet, what happens is that head pressure then causes it to undermine, and we get jetting action happening. And I have documented time after time again, turbidity values downstream, down gradient, immediately down gradient of fiber roll, which is meant to be a BMP, higher than what they were before the BMP, because that fiber roll is actually causing the problems. That wrong or bad installation of fiber rolls is causing bad turbidity numbers. It would have been better if they hadn't put it there at all. And so again, bad installation or wrong control measure will cost money. And so people ask, aren't they all the same? And that's kind of what we were getting at earlier. So let's kind of review some of these. If you've been to one of my talks, I'm sure you've seen some of these slides, so bear with me if you've seen these before. But it's a good review, and it's something that I think is still not quite understood in the field by those people that are installing them or using them. So again, a fiber roll, how it works is it just slows the flow, and it allows the particles to drop out. It does not filter. It does not filter. And again, you know, this joke's probably getting old, but there might be one of you that hasn't heard it before. You know, I can prove that that's not a filter. And how so? Well, you've heard the story of 3 little pigs, right? What did one of them build their house out of? Straw, right? Yeah. And even in third world countries today, many places around the world, what do they put on the roof to keep the rain out? Straw, right? Why? Because it filters so good. No, it actually repels the water, most of it. It mostly keeps it out. And that's what, when you stuff straw into a sausage casing and you stake it down, it's going to act like a dam. And that's why I was saying, you want to make sure your dam is secure. If it can undermine, then you're going to have a dam blowout, and it's going to cause water quality issues. Now, the Compost Sock is another version of a sediment control, a perimeter control. And this looks similar, except it's green. And it acts similar in many ways. It does slow the flow down. Now, the difference being is that because it's filled with a wood compost material, it also acts as a filter. So in this case, water does pass through it. The little pigs did not build their house out of Filtrex. The water passed through it, and it will remove a lot of sediment by capturing it in the sock itself. Now, one of the aspects or characteristics of a compost sock, and you know if you've ever tried to lift one when they're wet, they're extremely heavy. They're heavy when they're dry. They're a lot heavier when they're wet. And therefore, that characteristic means they conform very nicely to the ground surface, and we don't tend to get that undermining or jetting happening. Plus, with the characteristic that they allow flow to go through them, an 8-inch diameter sock will let flow go through in around 7 gallons per minute per linear foot. A 12-inch diameter sock is 11 gallons per minute per linear foot. So in that they're heavy and water can pass through it, we don't get that undermining issue. Therefore, they don't really need to be staked down when they're on flat ground, and that gives them a lot of ability to be moved a little bit, adjusted, and they're a great BMP. Now let's look at fiber roll, which we saw, and compare that to something else called what we call a curb cutback. And this is where we go from a soft scape to a hard scape. So maybe we're going from dirt to a gutter, or dirt to concrete, or dirt to asphalt. And as long as our flow is going towards the hardscape, this is a place where this might work. And this is where we would take like a GAN and a skip loader, cut down maybe 4 to 6 inches so that there's an elevation difference. Now, as the water flows that direction, does the water know that it was now stopped by concrete versus straw? No, right? It just knows it stopped. And when it stops, particles need to settle out. So a curb cutback is an awesome perimeter control to use in those situations that allow it. Now, what we've talked to a lot of people about is one of the real drawbacks is that it doesn't look like a BMP. And that freaks a lot of people out. One of them is the inspector that shows up, the municipal inspector, sometimes the water board inspector that shows up. They don't see a BMP there. Now, these days, I think more and more inspectors have been trained on recognizing them as BMPs, but we still get some pushback by someone going, there's no wattle there. Now, the other party that it's a problem for are the workers on site. Doesn't look like a BMP, therefore they're not thinking BMP, and they're not careful with maintenance. Or if they need to get a wheelbarrow from the dirt to the sidewalk, they'll dump in a dirt ramp or something like that. So a little bit of training is going to be needed if you're utilizing this on a job site to make sure, hey, everybody, make sure you maintain that 4 to 6 inch elevation difference so that we get good sediment control. And then as particles drop out, of course, maintenance is going to be needed no matter which of these you use. Fiber roll versus silt fence, we talked about that. What's the difference between these? Well, we talked about cost earlier, and I told you that silt fence is actually cheaper on a per linear foot than fiber roll. But the real difference here is which should you use? Well, the height is the real difference. And really the difference here is sediment load. When I'm expecting a bigger sediment load per storm event, I tend to go with silt fence because I want more capturing ability than the 3 to 6 inches that I might get with a fiber roll. Ultimately, we tried to design these for 50% of their height in capture volume. So, you know, fiber roll is 8 inch, so maybe 4 inches is our optimal capture volume compared to a 3-foot silt fence. So 18 inches would be our optimal capture on the silt fence. So we will specify silt fence like at the toe of the slope or at a place where we're expecting a potentially much greater sediment load is where we'll do that. And again, neither one of these are filters. Their sole function is to slow the flow and get things to settle out. So here I got some examples of different fiber rolls that have been installed and are either not functioning or need maintenance quite badly. And you've probably seen that. In fact, this one here has silt fence and a fiber roll here, but yet you can see that site management and lack of maintenance is really showing here. This site really needs some help. Here you can barely see the fiber roll. We call this pancake wattle, and it's not doing anything for them. And here we have something that looks very good, but this is what I call window dressing BMPs, because although it looks very good, nice, clean BMP here, you notice there's no stakes. In fact, it's not keyed in. And really, you'd probably be better off not having that there than having it there improperly installed. And then here's another place where sediment controls, linear sediment controls can be used, and that's on a slope. And this obviously has some severe erosion problems. And what is the problem? Can anybody unmute yourself or text me? What's the problem here? Is it how the fiber roll was used? Who can tell me? Anybody? Clarence, I'm going to pick on you because I know you know the answer. Find that mute button, Clarence. There you are. Well, all right. Well, I got a shy class today. So what's causing this? Couple things, but the big one is run on. The run on coming probably from the roadway up above there is what caused the problem. And you can put the best sediment controls, the best linear controls on the slope, but if you're not addressing run on and you still got places of concentrated flow, especially on a sandy slope like this is, sand will give you some of the most dramatic erosion failures, and this is no exception. And so this one had sediment controls put in place, but it was lacking run-on controls, and then probably also, because we don't see any here, it was lacking erosion controls. It didn't have an effective erosion blanket on there. But this would be caused by run-on. All right, so that was perimeter controls. Let's talk a little bit about effective soil cover. And this is too where there's a lot of misconceptions about what's needed and the overall cost of having to do the right thing. So erosion starts with the raindrop. When junior raindrop hits the soil, that's when it starts. That raindrop, and each and every one of those raindrops breaks loose soil particles that are now free to be mobilized across the site or off the site. And so the name of the game is to keep the raindrop from hitting the soil. And that's why we go back to schedule as our #1 BMP, because if we can do the work when it's not raining, we're going to be so much better off. But a solution I've seen a lot of commercial sites use that are relatively smaller is like you see in the picture here. They'll roll out plastic and when they get a predicted rain event, and they still have their sediment controls, they still have their drain inlet protection, they still have their conveyances protected, but they roll out plastic to keep junior from striking the soil, and that allows them to then not have the erosion. The other huge benefit of doing that is that it keeps the site dry. So earlier we were talking about when we get those real wet winters and everything's turning into pudding, having the plastic down during a rain event, putting it out allows, keeps the erosion from happening, but then keeps the soils drier and hopefully keeps the workers happier because they're not walking in calf deep mud across the site. And so that is a real good BMP to keep in your back pocket. Now, obviously, you're not going to do that on a 10-acre site or even maybe a 1 acre, well, maybe a 1 acre site, but usually the smaller sites or smaller areas of soil disturbance do really well in that. So also the strategy is to get that permanent installed earlier. And we were talking about paving things earlier, but it's also getting your sprayed on applications done earlier is very beneficial too. Not waiting until the rainy season. One of the big reasons is once it starts raining, then our options may have gone away as far as what products we can effectively use once the soils get wet, or worse, if it's raining while we need to apply this material. So if we have the time to spray on a bonded fiber matrix or a hydraulic mulch that can cure for 3 to 5 days, then we can go with some products that are typically less expensive than getting our backs up against the wall in a wet situation and having to apply a heavier duty product that is more durable in saturated conditions. That would sometimes cost 3 times more than a spray on that we could just needed to give a few days to cure. And then when it comes to an effective soil cover, a temporary effective soil cover, there's no bigger bang for your buck than straw. We are a big fan of straw. For small areas, there's nothing beats going to the feed store and getting a few bales of hay and hand scattering it. Especially in this area, if you go to the feed store and you're picking up bedding straw, most likely it's oat straw, and you're going to get an added benefit of seed. You're going to be growing an oat crop. We have on many sites have oats coming up. Now, you need to be aware of that too, because there's places you don't want that to happen. But there are other places that is a great benefit. So hand spreading out some straw, and we've done demonstrations when we used to have live workshops or in-person workshops. Some of you have been to our workshops. 2 people can spread a lot of straw in a few hours. And so you can cover a pretty small area. But once you start getting bigger, you need to have it maybe machine spread, and then to apply a tackifier on there. But it's still a great cost-effective BMP. And the other reason we really like straw is that it's durable. We've done tests here where we've had it applied in our construction sandbox, and we've seen it go through up to 3 seasons and still be quite an effective ground cover. So it's very durable. And then track out control. Let's talk about this a little bit. We already talked about when to put them in. That's usually the trick, is when to install them. Now, obviously, you need to get them installed before sediment is being tracked out onto the roadway. But there's a timing issue there, and you want to work really closely with your SWPPP writer so they understand when you're intending to install it, and also that your QSP understands that as well too. These things, when they're installed correctly, are not cheap. Our test one you see on the screen here, that one was about $5,000 just to install that. And so you want to select your locations. One of the best track out control measures that I know of are K-rails and orange cones, delineators, basically to prohibit exit from certain places on the job site. Sometimes that's the best thing you can do, especially if there are 1 or more track out measures that are accessible that they can use. Many times people, they want to take the shortest way to get out. But if there's a K-rail or there's delineators blocking it, then they'll find the right one eventually. So use that. And also, when you do build these, build them so that the center is the low spot. Never build it so that the street side is the low spot. Because I've seen contractors get written up by the water board inspector because their track out control sloping to the street, and all that mud that deposited out now in a heavy rain event is being washed to the curb and gutter. So we like to get them to go to the center, which in the picture you see here is where that grizzly is located. And then where you see that white 5-gallon bucket off to the side, that's actually a 5-gallon bucket that has holes drilled in it. And we put in a sump pump in that. And so as that sediment trap fills up, we can actually transfer that water to another place on the site where it's not going to flow off. Or if we need to maintain that device, we can take a fire hose to it, wash it off during dry weather to the center, get all that sediment out of that rock and get it to go into our sediment trap. And then we can take our backhoe and clean it out that way. Both of that, if you do that, you're actually following the Casco or the Caltrans TC1 standard. All right, and I saw a note from Brian, and that's exactly the next slide, Brian. Thanks for the cue. Yes, I am becoming a big fan of these. Now, again, I have actually no business dealings with pods, so if this is a commercial, it's not a paid commercial, but it's a better mousetrap, if you ask me. The reason I like these, especially for highway projects or for projects that transition a lot, is that these mats can be picked up and moved. And they're easy to maintain. They're easy to relocate. And I really am a fan of them. They can be configured in different, they can be made wider, longer. They're very workable. Now, the only drawback is they are a little bit pricey. I think, if I remember right, I think they were about $2,500 a mat, if I remember right. But if you do work continuously, though, that may be a great deal, because when you put in a $5,000 track out control, what do you actually get out of that after the job's over? Maybe the grizzly, but not much else. The rock and all that just, you lose that. So, if you're putting in track out control often, this might be a good investment. And I really have become a fan of these. And there's other suppliers out there on the market. All right, so ultimately what we're aiming for is final stabilization. And whether you're the SWPPP writer or whether you're the QSP implementing the SWPPP or you're the LRP's representative, you want to understand what's needed to get out of the permit and to get your NOT accepted. And boy, believe me, these days, the Water Board is returning most NOTs these days for various reasons. They really have ratcheted up the requirements, both for on-site controls and stabilization controls and documentation of those, and as well as making sure that the post-construction design measures were properly installed and that there is a valid maintenance agreement in place. So, a little bit of compost and wood mulch will go a long ways to getting your NOT approved. We have literally seen times, even recently, where there was only a few square feet of soil present in the picture, visible in the picture of bare soil. And literally a little bit of wood mulch would have got that accepted, but the NOT was denied because the Water Board saw bare soil. So compost and wood mulch is considered a permanent BMP. Now, what's not accepted is temporary BMPs any longer. So even though you paid to have the hydraulic mulch blown onto the site and you took pictures and you can see that aqua bluish green tint of the hydro mulch on the hills, that's obvious that it's been coated. The Water Board won't accept it until they see the hydro seed germinated and the green growing. So make sure that you plan ahead and that you get your site stabilized. And all right, I think that's pretty much it. Again, timing is everything. You want to make sure you get good, successful germination. This is a little bit of a plug for one of my workshops on Wednesday. I'll actually be this is a project of mine. I worked with the Yosemite National Park Service on the Ahwahnee Meadow restoration project, and we'll be talking about this on Wednesday. So join me, I think at 10:30 Wednesday. If all goes well, I'll be live streaming from this meadow in the right under Half Dome. All right. So with that, I think I'm just about out of time. I want to stop my share and take any questions if there are any. Let me see what my chat is saying here. Or feel free to unmute yourself if you have a question or comment. Just looking at who attended today, I think I was preaching to the choir. I see a lot of QSPs. So, all right, any questions? All right, well, I want to thank you for joining us for this Stormwater Awareness Week workshop. And I hope you can take advantage of some more of the workshops during the week, and feel free to drop us a line, say hi anytime. So thank you for joining this one. We'll see you in one of the next classes.
Thanks, John.
You're welcome.
See you tomorrow.
Thanks, John. See you tomorrow.
All right.